exact same technique here. And I'm going to be smart. Remember this alignment? Let me bring back the labels. So there's the labels, right? So I know that 0, let me get rid of some of these. Oops. This one here. Okay, so here's station 0, here's station 20, here's station 40. So in the direction of increasing chainage along the gutter, the left side has the boulevard, the right side has the pavement. Okay, that's the orientation of the alignment, and that's why I created my subassembly to look like this, right? There's my gutter. I have the boulevard on this side and the pavement on this side. I want to reuse this. I don't want to have to recreate another one, so I'm going to be mindful when I create my alignment here. So let me turn off this just for a second. I'm going to freeze this again. Oops, too much. So I want my, let me get rid of the water and stuff. It's in the way. And we'll just deal with the edge of pavement. Okay, so remember the last time we have a standard 20-meter right-of-way is where the widening starts, right? So right here, these two dots, that's the last time. So I'm going to draw that in from here to here. So, you know, along here, all the way to this point here, we have a standard 20-meter right-of-way. Then there's where it changes. So I want to create an alignment along the gutter line that goes all the way around and back again. That's the unusual, non-standard part of this. So what I want to do is I can trace it with a polyline. I can copy the lines. There's so many different AutoCAD ways of doing this. I'm going to use a polyline. So I'm going to turn my O-snaps to endpoint. But I will call the nearest one as well on the fly. So I'm going to draw a polyline. And I want to start not exactly where the widening starts, but just before. So I'm going to type in near, N-E-A for near, O-snap, and I'm going to start just before. How far before? Doesn't matter, but just something, because I don't want to design to the limit. I want my profile design to be inside my horizontal alignment. So I'm going to start here. I'm going to go to the end. A for arc. L for line, near, and there's the polyline that represents the alignment I want to create. Now, because I want to reuse this this assembly with subassemblies, I want to make sure that my alignment is oriented so that the boulevard is still on the left side. So to do that, I want to make sure that when I create an alignment from this polyline, 0 is on this side, so that when I come around, this is the boulevard side. Okay? If I put 0 on this side, that's not wrong, but if you do that, then you need to create the mirror. You have to create this with a boulevard on the right side. Okay, so that's the difference. So I don't want to do more work than necessary, so I'm going to strategically make sure that 0 is on the same side. 0 is going to be on this side so that I can make use of that previous cross section. So we go to alignments. So remember the name of the center line, because I'm going to reuse it. So I like to cut and paste. I don't like to type all the time, so I'm going to reuse this, copy. Okay, so alignment. Create by polyline. I'm going to pick this end, not this end. I want this end because I want 0 to be at this end. And when I hit enter, see the arrow is telling me the direction of increasing chainage. That's correct. It's going to start here and go around this way. Enter, give it a name. And I always just give it the name cul-de-sac. Cul-de-sac. And this one I'm not going to index. There's typically only one cul-de-sac on a road, right? Not two. And turn this off. So give it a name and turn this off. We don't need extra curves. Say OK, and there's your horizontal alignment. Okay? You don't need all the labels. And then just double check. 0 is at this end, 20, 40, 60, 80. It's going around the way I want it to. Okay? So I can get rid of the labels. Okay? Nobody needs to see this alignment. Okay? It's only for the purpose of the model. So now what I want to do is I'm going to create my existing ground profile along the gutter on the cul-de-sac. So here's how you do that. And then I'm going to place it right on the end, at this end here. So I'm going to go to Profile, create profile from surface. It's the cul-de-sac now. I'm going to see the existing road, add it. You can add the proposed road too. I'll demonstrate that later because that's how the PDF shows it, but I just need the existing ground. I've added it. I'm going to change the style right here so that it looks red dashed. I want to see existing ground red dashed. And then I'm going to draw it in the profile view, and I'm going to make sure to use the road style so that it looks like this type of style here. And I'm going to create the profile view. I'm going to pick the end of the street. Remember, this is the beginning, so this is the cul-de-sac is at this end, so I'll put it in the middle at the end. So there's my existing ground profile all the way around the bulb. You don't need these white labels. Okay? Existing ground is just a graphic thing. So that's what the existing ground looks like. The only reason we add the existing ground is just for reference, so that the grid doesn't come in empty, because I want to add to it, right? Otherwise, it'll come in flat, right? If I don't create this data, I'm going to delete it. It comes in flat, and you can't see anything. So it's good for reference. It gives you the elevation range you're working in. We don't see the pop-up window. Oh, sorry. You don't see the pop-up windows. Sorry, I'm just reading some of the comments. I got ahead of myself. Oh, I see. Okay, I'm going to share my entire screen. My apologies. Sorry about that. I'll go back. I'm going to go back. I'm going to stop this, and I'm going to backtrack a little bit. So I'm going to share my entire screen. Sorry about that. Watch me do here. Okay, can everybody see my screen now? And if I use, if I list, can you see that pop-up screen now? The Autodesk text window? Okay, I think that's better now. My apologies. Okay. Do I need to recreate the alignment? Do I need to recreate this in plan? Is everybody okay with that? Can I continue from this point? I'll redo the profile. Do I need to redo the horizontal alignment for the gutter? Yes, I will. Okay, so I'm going to delete it and I'm going to start over. So first you need the polyline. I'm going to draw a polyline. Don't start right at the beginning. Start a little further back and then go all the way around. So I'm going to start near and then end point A for arc, end point, end point, end point, L for line, and then I'm going to snap to this point here. So there's my alignment. A little bit more at the beginning, a little bit more at the end. To create the alignment, we go to alignment, create by polyline. I'm going to pick this end because I want 0 to be on this side so that the boulevard is on the left. There's the direction right here. That's correct. Enter. And I'm going to give it a name, Street A. Call to sac. And then turn this off. Okay? That's I've created all the alignments so far. Say OK. And then just double check that it's going the right way. 20, 40, 60. Yep. Okay. So I'm going to delete the labels. I don't need them anymore. I'm going to create the existing ground profile of that alignment. So profile, create from a surface. Cul-de-sac, existing ground, add. I'm going to change the style so that it's red and dashed. Road existing. I'm going to draw it in the profile view, change the style to the one called road. Create a profile view, I'm going to put it on the end, and then you can delete the labels. You don't need the labels for the existing ground. Okay, so I think I'm caught up now. So the next thing I want to do is I want to bring back the corridor model for just a second. So I'm going to bring back the surface model, not the actual corridor model. So let me bring that back. So here's the surface for the road that we created before. Right, and you remember, I'll show it to you in 3D, object viewer. You'll remember that we did the widening out here. Now I want to do the bulb out here. Okay, so right now, from this point, this is the last time we have a standard 20-meter right-of-way. Okay, so everything after that going into the bulb is wrong, okay, except for 3 key points. Okay, the 3 things that are still okay are the gutter elevation. So if I click on my alignment, the gutter elevation right here is correct. The gutter elevation right here is correct. And the gutter elevation right here is correct. Okay, right here. So what I want to do is make sure that this surface covers that area. Remember we made it shorter so that it ended at the at the edge of asphalt. Okay, so there's a couple of things to be mindful of. I'm going to take this, not this, but the corridor model. So I'm going to bring the corridor model back because I have to revise the corridor to change the surface. So the corridor model is now here. There's the grip for it. So I'm going to make it go all the way to the end, and it's going to create a spike, which is fine. Okay, so if I look at this surface, it's going to have a spike at the end, right? So I want to know the elevation in the gutter, right where the center line crosses this surface, okay? And it's going to be wrong right now because if you remember, we didn't design to the gutter. We designed all the way to the edge of asphalt. So there's a piece missing. So there's a surface there, but it's not representative. So I have to go back to my profile. Okay, I'm going to go back to my profile, and 0.3 meters away, I want to put in my gutter. Okay, and remember the slope of the gutter? Anybody remember? The slope of this piece here? Carl, that's right, 8.33. So I'm going to do this. I'm going to come in here. I'm going to draw a line. I'm just going to go 0.3 meters, so I have somewhere to target. I have the station I need. I'm going to grab this, right-click, edit the profile geometry, add a PVI, put it right on the end. So now I have a station, but the elevation's wrong. No matter. Grab this, go to the table, and go to the very end in the grayed out column, negative 8.33. And there's my gutter elevation at the end. And it's vertically exaggerated, remember, 5 times. If you want to draw the entire boulevard, you could do this. I'm going to draw a line at the end. 0.05 is the next width. Think about the cross section. 0.15, the top flat of curve, and then I can put in 5.55, the actual boulevard width. And if I do that, right, now I have all the station values. I can add more PVIs. There's going to be one right here, one here, and one at the end. And then I can change the slope. Watch this. I can start here. So if it's negative 8.33, now I'm going to go positive 300. There's the face of curve. Positive 300. Sorry, where'd it go? Oh, sorry. Typed it into the wrong column. This should be negative 8.33. And then the next one should be 300. And then the next one should be 0. This should be 0, and the last one should be 2%. So now I've drawn all of the, I can get rid of some of these labels. I actually drew in the profile, I drew the cross section of the boulevard. You can see all the points here, and it's vertically exaggerated. Okay, so now the model goes all the way to the end. So if you go all the way to the end, which I hope it does, I hope there's no gap there. If it goes all the way to the end, then there should be no spike on the surface. Okay, so if you rebuild the corridor, right, if you ever get that little shield, that warning, you just rebuild it or set it to automatic. It rebuilds, and that should get rid of the spike at the end now, because now there's more profile. Object viewer, and you'll see that it's gone, and if you zoom in, it's going to look kind of funny, but it'll look like a curb and gutter. You see that? It looks like a curb and gutter. It's kind of silly right here, but that's what it is. So as much as this is wrong, 3 key points are correct. And I'm going to draw some points. I'm going to draw an AutoCAD point right here at the end of the curve. At the end of this curve, that's the gutter on one side. The end point of this red curve here where the alignment is. There's the beginning. Turn off my... this one here. So there's a point there. And then right here, in the gutter, right here, there's an elevation. Okay, which is where the center line of the gutter meets the center line of the road. Right? That's where I put my point. So as much as everything is wrong in this entire area, this elevation is what it is now and will be when I'm done, and so is this. That's where I match, right? So my profile design, station and elevation here and here is correct. And as I come around, the station and elevation of the gutter is correct here as well. So those are the 3 points that define the profile of the gutter. Okay. So if you missed that from last day, here we have 3 points. Last week when we were looking at the crescent, we only had 2 points. Okay. So the one thing that's I left out was finishing the profile, right? This thing here. You definitely need this point here, because that's the point in the profile of the gutter that you're going to need to design to. Okay. So we left that out last time. All this other stuff, this is just a filler, right? This is just for reference. You don't need any of this to do the design. Okay. As a matter of fact, this will be taken care of when I go around the cul-de-sac. Okay. But this point is critical right here. You need this elevation. So here's what we do with those 3 points. I'm going to grab that point. That's the beginning. There's basically in the middle of the profile, and here's the end of the profile. These 3 points give me the station for the PVIs in the profile of the gutter of the cul-de-sac, and the surface that we're looking at will also give me the elevation of those 3 key points. Every other point is wrong in terms of their elevation, but those 3 are correct. They are what they are now, and they will be what they are now when I'm done. Okay, they're just going to have a different way of getting there around the curves. So what we do is we project them to the profile. Let's get rid of this. Project them to the profile. So we go to this button here, profiles. Project objects to the profile view. We pick the grid. I've already selected them. Did I select? Yeah, so I've already selected the points. So you can pre-select, right? So I'm going to pre-select 1, 2, 3. If you don't pre-select, you have to select them after you start the command. So I'm going to project those to this grid here, and I should get 1 on this end, 1 in the middle, 1 on this end. Don't use the 0 elevation of the object, right? Whatever comes up here, don't use the object. Change it and get the road elevation. These are the elevations that come from the road surface. Okay? And notice 2 of them are the same because they're directly across the street from each other. So that's a bit of a clue. Say OK, and the 3 points come in. And then you do exactly what you did here. You have to create a design profile that connects the dots. So before I do that, I'm going to change my O-snaps. Change my O-snaps to node. And then you go to profile, create profile from layout this time. Pick the grid, give it a name. I always repeat the horizontal alignment. I put an FG on the end for finished ground. I say OK, and I can start drafting. So for this one, make sure you've got the correct street that you're working on, and then put in the 3 PVIs. 1 here, 1 here, and 1 here. And what do you think the slope of those lines is going to be? Any guesses? Greater than 1%, correct. Stephen, yeah, the points after the gutter you don't need. Okay, I just put them in for reference so you know what the gutter looks like with respect to the rest of the cul-de-sac. You really only need the gutter point in the profile. So now when I hit enter, it's going to put in the labels, and that should not be a surprise. That should confirm that you did your profile correct. The reason these are a little bit steeper than 1% is because we determined what this slope needs to be to guarantee it. We calculated something a little less, we rounded it up, so the gutter is going to be a little steeper than the 1%. So we started with 1%, we calculated what this slope should be, we rounded it up, which means the slope from the gutter all the way around both sides to the entrance of the gutter should be a little bit steeper than 1%. So again, this is not a surprise. It's confirmation that you did your work correctly before. Okay, so I'm not designing anything here. I'm just creating the explicit data required for the modeling. So now I have, just like any other corridor, I have a horizontal alignment, I have a vertical alignment, and I have a cross section. The same one. I want to drag this all the way around. So now I have plan, profile, cross section, the 3 basic building blocks of a corridor. I'm not going to create a separate corridor. I'm going to add to the current corridor, and I'll have one model that shows all this. Okay. Let me turn off the surface for just a second. Surface. Turn off the view. And there's the corridor. Now you got a couple of options here now. You can split the region so that you can turn this off, or you can delete it. Okay, the way the PDF demonstrates it is to create a region and turn it off. So this is what I would do. It actually drags it back. You can take this and say, okay, only build up to this point here, because everything else is wrong. That's one way of doing it. I think that's what's in the PDF. Another way of doing it is going to the corridor properties, go to that parameter, the last region, this one here, the last one. I'm going to split it again, so there'll be, instead of 3 pieces, 4, so split the region. Where do you split it? Exactly at the entrance. Click here. When you're splitting the region, as soon as you're done picking your split points, say OK and let this rebuild. Don't make any changes until you let that whole process complete itself, and then you can go back and change it. So now you can see we have another split here. There's some grips that show up. If I go to the corridor properties, you can clearly see that's the beginning, that's the elbow, that's this piece up to here, and that's the last piece. So instead of eliminating it by grip editing it back the way I did previously, I could just turn it off in case I ever need that information back again. So here's, instead of deleting the data, I could just turn it off and not build it. Okay, so that's another method. There's more than one way to do everything. I like to keep this piece in case I need to go back to it. Right? If I ever need the, like right now, if I turn that off, right now, the elevation of these 2 points may or may not show up in the profile because they're right on the edge of the data. And this one here has no elevation. Let's see what happened to the profile. See, that point is gone. That projected point is gone. This point is here. This point is here. And the one in the middle is gone. Why? Because there's no surface there. Right? So it has no way of getting its elevation. Let me do this again, right? I'm going to turn this on, click. I'll do it over here so you can see it happen. I'm going to right click, go to the corridor properties. I'm going to turn that piece on. That'll generate the surface up to that point in the middle. Say OK and watch what happens. Now the point should reappear. So now it has an elevation to get. Okay. Now because this profile design connects the dots, it's not dynamically linked. So if this changes, if the elevation of this point changes because the surface changed, you'd have to adjust this manually. Okay, so for instance, if I go to my profile, suppose I've made a mistake here. If I change the elevation of the profile here, I need to reproject this here, and so on. So suppose I wanted 2%. So let me redo this, just as an example. If I go to properties, sorry, not properties, geometry. So now I'm dealing with street X profile, not the cul-de-sac. Instead of the 125, I'm going to use 2%. I'm going to make it much steeper. And then I have to adjust all of these. Negative 8.33, 300. Remember the last few you don't need. You only need the 833, 300, 0, 0, and 2%. Okay, so I've changed the profile of the center line of the road, which then changes the design of the, or the model of the corridor. So this elevation now is dynamically linked. You're going to see that X in the profile of the gutter go up a little bit. All right, so if I rebuild the corridor, see, it went up. So then if I want this to match, I have to manually put it there. And then I get an even steeper gutter. Okay, so this point is dynamically linked. This profile that you use to create that you use the points to create is not dynamically linked. Okay, so you got to be careful about that. Okay, so if you make a mistake, you have to adjust this. You have to adjust the profile if you made a mistake. The corridor will automatically do its thing. The point will automatically reproject. But anything you created from that, like this profile, then has to be manually adjusted. It's not dynamically linked. Okay. Let me do the whole thing backwards to get it back to where it was. So if you change your profile, if the profile is wrong, whoops, that should have been 125. So I'm going to right click. Notice the name's going to change up here. Go to the geometry of the profile. I'm going to change the slope, not 2%, but 1.25. And then everything else kind of dominoes. Negative 8.33, 300, 0. And positive 2. So that's going to, that profile now is defining the corridor is defining the surface is giving this point its elevation in the projection, in the profile. Right, so all I have to do is rebuild the corridor, just give it a, that's the digital equivalent of, kicking it so that it behaves properly, and then I say, oh, okay, so I made a change, now I need to adjust this design to match. And that works out. Okay, so some of the stuff's dynamically linked and some of it isn't, unfortunately. So you have to kind of know that. And when you see something's misbehaving, it might be a matter of either making that manual adjustment or rebuilding something that's out of date. Okay, so the same, it starts from 0 from now. Okay. Another question I see for the back, Sumitra, sorry, I wasn't ignoring you. Can I use the back curve instead of drawing a new polygon? You can, however, the slope you get here then would represent the back curve, not the gutter. It'll be close, it'll be very close to 1%, but it won't be exactly what the gutter grade is supposed to be. It's not wrong, but certainly you can do that. The thing to be aware of is if you use the back of curve, then you have to create your assembly so that the center point represents this position instead of this position. So just be careful, right? Wherever you put the alignment in the plan view, you have to build your sub-assemblies correctly based on what the reference point is, right? So remember over here, the reference point, the alignment is in the center of the road, so I build everything according to that being the center of the road. Then in this one here, the alignment is the gutter, so I build everything understanding that that represents the gutter. In your case, this green line would be right here. Right, the back of curve, and then you have to create everything accordingly, right? So the widths would be the same, but maybe your slopes might be plus instead of minus. Yeah, and in the PDF, it actually shows the alignment here at the edge of asphalt, as opposed to the gutter. I like to use the gutter myself, because then I get exactly the slope in the gutter, exactly the slope in the gutter. Okay, if you use the edge of asphalt or the top front of curb or the back of curb, they're so close to each other, the center line length is so similar that the slopes will be very close. But as the length gets a little bit longer or shorter, and again it's going to be very little, you're going to get a slight variance in the slope. Instead of 1.14, you might get 1.13 or 1.12 or 1.15. It'll still be in the right spot. When you try to drag it down, profile view got extended. I'm not sure what you mean, Trump. It's when you move the corridor grip. I'm not sure what that means. So that's the profile design, or the profile input. Okay, you guys sorted it out, good. The other thing that the PDF says is you should project into here the corridor model. Let me show you what that looks like so you can relate it to the PDF. You don't need to do this, but it's good for reference. Instead of projecting these 3 points, you could project the surface, the corridor surface, before you add the cul-de-sac. So even though it's wrong, you can still see how the current surface shows up in this profile. Okay, so watch this. So profile, create from surface. For the cul-de-sac, I'm going to add the proposed roads, and I'm going to make it green. I'm going to make it look like the future road, and then it's already going to, because it's in that road, it'll add it to the view. So you don't need to draw a new view. Say OK. And then it'll show up here. So if you look here, you'll see this is what the profile of the surface looks like. And notice there's a gap here. Well, those gaps represent the fact that as you go along this alignment, you're out of the surface range here, and then you come back into range here. Then you see this, what looks like a section. Then you're out of range here, and then you're back in range here. So these 2 spots that stick out outside the limit of the surface show up as blanks. There's nothing there, and that's what that looks like here. Right in the middle, it looks like a cross-section, kind of. If you notice that this surface, this point is on that surface, this point is on that surface, and this point is on that surface. Those are the 3 points that are true, that are correct. Everything in between those 3 points is wrong. What we want it to be between those points is this, and that's what we do. We force it to happen. Okay, so this is just for reference if you want to see that. You don't need to put that in, but the PDF example shows that. You could just bring this in and connect the dots of this position to this crown to this position here, but you may not know exactly where they are. I like the point method. I still use the points even if I show this, right? But you don't really need this. So let's add the 3 pieces to this corridor model. So I'm going to grab the corridor and go to the corridor properties. I'm going to turn this one. I'm going to turn it off. I don't want to model that one, right? You don't have to leave, but I just want to see that it disappears. And then I want to add to this another baseline. So far we have 3 baselines, right? The main road, let me zoom out so you can see, right? We have 3 baselines for this corridor. Sorry, 2 baselines. Right, we have the main road, and we have the alignment around the gutter on the crescent. And we're going to add one more, the alignment around the bulb. So I'm going to use Add Baseline. Again, you can pick it from the list, or you can use this green button to select it from the screen. So I want this alignment. Say OK. Then I want to, if you expand the view, tell it what profile to use. There's always 2, existing and proposed, so be careful. Right? Make sure you use the green one, the design one, not the existing surface. Say OK, and then you'll notice these 2 have these pull downs, right? These expand buttons, the plus signs. So to add the region, you right click and you say Add Region. And that's where you add the cross section. And what you want is the crescent with the boulevard on the left side. Okay, so I'm going to reuse that one because I strategically chose 0 on this side to go around this way. Say OK. Let me build what I've done so far so you can see what you have to fix. Okay, you don't have to stop and start the way I am. I just want you to see the effect of the different functions. Okay, so I'm just going to add those 3 pieces and let it go. So now it built it. Looks kind of funny. Right? Doesn't look circular. No matter. Let's fix that. That's a frequency issue. So let's look at the frequency. So by default, the frequencies are all 25. So let's go into here. So if you go to I'm going to set all the frequencies again, right? So they vary because by default they're all 25. I suggested always use 3 on the tangents and 1 for any type of curve. Okay, there are no spirals, there are no vertical curves, but it's just a habit. Make all the curves 1, make all the tangents 3. Say OK, and it starts to look like a cul-de-sac. Okay, so now it started here and went all the way around and went back again. Then you see this hole in the middle. The hole in the middle is the same issue we had here. Remember, there was that kind of break in the pavement. What we need to do is exactly what we did here. Just the geometry is different. Is we want to take this piece, the pavement. Let's go back to the cross section. I want to take the pavement piece and use that targeting function to make it longer. I want to extend these all to the center line horizontally, and vertically I want it to match the elevation of the center line. Okay, so that's a targeting issue. Okay, so we do that again here, and I'll show you. I'm not going to show you in 3D. I'll just show you on the dialog box. So we'll go to corridor properties. So for this region, I want to go over to the targets. So this one here, and remember, all the targets have the same name, and I changed the name of one of them so I can find it. And you'll see that here. See, there's one called pave. Sorry, question. How do you get rid of the exclamation marks on the corridor properties? Over here, on this side. If there's an exclamation mark here, you need to rebuild. Okay, so let me set these targets. So the target for this region. So the one called pave, that's that piece of asphalt. Horizontally, I want it to go to the center line of the main road. So that'll extend it to the middle of the road. And vertically, around here, and the elevation targets for this one here, I want it to go to the same road, the center of the road, match the proposed design of the center line of the road. And if you want to see the full name there, it should be expanded. Say OK, and then watch what happens here. Say OK, they all go to the middle. Horizontally, you saw the effect. Vertically, you didn't, but it does match now. The corridor properties. properties. Are there warnings in the dialog box or in the tool space? Where are the warnings? In this dialog box or down here where the tool space is? Dialog box. I'd have to see yours. I'm not sure where you would mean. I don't remember seeing any of those. Do you see them like right in here? Right in this space here? Yeah, usually that's what happens. Try it though, okay? Again, the software is great, awesome. It's not perfect. It's got a few little quirks about it that you have to get used to. So let me say okay to this. And then based on that, I can bring back the surface. It's constantly being built in the background. So let's change this as standard. And there's my surface. And you'll see it's got a couple of spikes. We're going to deal with that. Okay, so pretty good, right? But there's a couple of spikes. And those spikes are the same issue we had on the main road, same issue we had in the crescent, if you've been working on the crescent. So I'll show you how to deal with that. Beside the baseline names, yeah, you'll have to try, you'll have to rebuild it. The only time that happens is if you delete something in the drawing that it's trying to use. It's confused if the data's gone. That's the only time I see those warnings. Okay, but if you have a specific question, we can look at your drawing later. Okay, we can have a private look. So I'm going to get rid of the surface, object viewer. I'm going to get rid of the surface, no display. Let me look at the corridor in 3D, and you'll see exactly the problem. Object viewer. Spikes are actually coming from the corridor model, and the reason for it is, you remember, the corridor, the start of the range for the horizontal alignment of the gutter is before the profile. So the profile design starts here and ends here. But at the beginning and at the end, the horizontal alignment starts a little bit before and goes a little bit past. In those areas, there's a zero elevation, right? So in the profile, right, it wants to build all the way to here, but there's no profile here. So it assumes an elevation of zero. Same thing on this side. It assumes an elevation of zero. So the solution is exactly what we did before. I'm going to click on here, grab the grip in the gutter, and snap it to the beginning of the profile design range. Grab this grip and snap it to the profile, which is this point. That gets rid of the spikes, object viewer, in the data, and that'll get rid of the spikes on the surface. So let's bring your surface back to life. And look at the surface in 3D, object viewer. And that's pretty good, not a bad surface. So that's what you're looking to do to create this finished ground surface. Okay? This surface is used for the front lot corner elevations, which I'll demonstrate again in a moment, and it's used for the top of maintenance hole elevation when you do your pipes down on the pavement. Okay? So that has to be good. The only thing I didn't do is the entrance, the elevation, the curves at the beginning. The reason I'm not going to do that is because this surface, what if you still see a spike in your surface after adjusting the corridor grips? Then your problem might be sloppy drafting here. So if this is a little bit, if you didn't snap exactly, if there's a small gap here, see what I just did? If there's a small gap here, then you're going to have the same problem. Watch, I'll show you. Let me rebuild the corridor. Let me show you the surface. I've got a spike on my surface for sure. Oh, maybe not. Should have created a surface spike. Let me show that again. If this doesn't quite match, sometimes it gets finicky. Right, so it's supposed to be over here. I'm modeling from here over, so it should have created a spike in the beginning. Just check it. Rebuild. Yeah, there it is. Right, so that's the problem. So if you grip edit it correctly, but your profile is sloppy, if you have a small gap, I've exaggerated, but I've seen some students that forget to use OSNAP, right? They use no OSNAP, they just eyeball this, right? Just by eye. If there's a little gap there, so you got to zoom in tight. It looks fine, right? But if you have a little gap there, it won't work. Let me just see if I can demonstrate that. So you have to be very tight with your drafting. Look at it one more time, object viewer. There should be a spike there. I'm surprised it's not. But that's why it would happen. Okay, so just be mindful of the profile. Make sure your ranges are exact, right? So this should be exactly at the node, this point here. Okay, so just be mindful. And then, if this point in the plan is in the wrong spot, and if this point is in the wrong spot, and you design it to there, but then you grip edit your corridor to the end of the curve on your alignment, then that will also cause a gap. So you have to be very, very consistent when you create this stuff. And that's why we teach you O-snaps way back in BEA001, right? You have to be exact with the position, because the same place may be used for many, many things, and if you're not consistent, then it's going to cause you trouble. Okay? So there's many reasons for it, but those are some typical ones. Okay, so sorry, the discussion I was having here. This surface now, as far as the front lot corners are concerned, I don't know if there are white lines in the surface of object viewer. Usually not, no. Usually you get surface, if you don't have a boundary, you might get some surface white lines here, you might get some surface white lines here. But if they're inside the limit of the right-of-way, then there's a problem. But if it looks nice and clean on the inside, right, if everything inside looks clean, that's fine. If you have any white lines to the outside, let me turn my boundary off, you'll see some. I go to my corridor definition, I'm gonna get rid of my boundary. You don't need a boundary. Okay, so if you don't have a boundary, it looks like this. So if I go to Object Viewer, you might see some white lines on this surface, right? But those white lines in a spot where you're not going to pull information from is okay. You can see this ripple effect and stuff. There's sometimes you get those white lines. It depends exactly where. But if they're inside, if they're near the curb and gutter or the center of the road, then they're a problem. So this surface, even though there's no boundary on it, out here it's wrong, right? In this area here, these long triangles, they're all wrong. But where I'm going to use the surface, it's correct. You don't need a boundary, you just have to remember not to get any elevation. Like the elevation at the back of the lot, I could get an elevation. Like if I hover here, it'll tell me there's an elevation. See that 163,532? There's an elevation there, but it's meaningless. The only true elevations are the ones when you're inside the right-of-way. That's the exact boulevard elevation at that location. Here's the pavement elevation at that location. If you go right into here's the gutter, that's the gutter elevation. Here's the top back curve, and so on. These are all true. Here there are elevations, but they're meaningless. They don't mean anything. So you can't use this surface in areas outside the true range. Yeah, and again, it has to do with how tight you are, Stephen. It has to do with how tight you are with your grip edits. Okay, if there's any gaps or overlap, it's going to cause you trouble. Let me see if I can create one. Right, if you create an overlap here, like if this grip goes further, right, if you pull some of that 20-meter right-of-way in, it starts to get a little confused. So you have to be very, very specific. You're asking me how long a piece of string is. I don't know. I'd have to look at your piece of string. Right? I have to look at exactly what you may have done. And if it's a combination of 10 steps, which one went wrong or which combination of steps went wrong, it's hard to discuss in this forum. I'd have to look at your data. So if you want, we could have a private meeting and I can just look at your drawing with you. Okay, so we can troubleshoot that later. Okay, so the boundary is not necessary, but if you don't apply the boundary, remember, don't use this surface in areas where you know it not to represent. Right? The only place this surface is good is in the right-of-way. Right? The other thing I left out here is, I'm not going to model this curve, right? The pavement coming around the curve. I'm just going to leave it like that. As a matter of fact, remember we designed our profile from the edge of asphalt of the existing road, right? Not the center line, but the edge of asphalt. Really, this surface only needs to go to, if you look at this daylight corner, this triangle, you only need the surface to cover this point and this point. These are points on the right-of-way inside the subdivision. Okay, so really, if you wanted to, you could grip edit your boundary, your cul-de-sac, your corridor to stop right about here. You only need to cover this space here. This point here comes from this surface, and this point here comes from this surface. Okay, that's the purpose of the surface. If you wanted to model the asphalt all the way around these curves, you could, but they're not necessary for what I'm going to use the surface for. Okay, so that's one thing I'm going to leave out. And in practice, when I do these subdivisions, you'll see next semester, you'll when you have a couple of roads interacting, what kind of a gap you want to leave there. The next road will come along between here and here, and it'll give you the elevation of this point, and give you the elevation of this point. right? When you have two proposed roads intersect. No, Stephen, it's equivalent. If you create an alignment at the edge of asphalt and create your assembly where the reference point represents the edge of asphalt and your profile, connect the dots for the edge of asphalt profile, that's fine. It's an equivalent model, it's just a different technique. So it's not wrong. If you do that, that's fine. I'm not going to mark it wrong. Okay, I just wanted to show you a variety of things and the importance of being consistent, right? So if you draw the gutter line, you have to model your cross section with the gutter line as the reference point. If you draw the edge of asphalt, you have to draw your assembly or sub-assembly parts, keeping in mind that the point reference is the asphalt and so on. So you need to be consistent. I didn't do that, but I can if you want. What time is it? Yeah, I can do that. So I'm going to turn this surface off. So you don't need to do both, obviously. I'm going to, let me freeze this. Right, so I'm going to offset by 0.3, the width of the gutter, that's where the asphalt is. Right, so you can create an alignment there if you want. That's what the PDF shows. Right, so I'm going to create an alignment, create by polyline. I'm going to start at this end again. I'm going to set the direction. Yeah. And I'm just going to call this asphalt. And I don't need any extra curves, and there's my alignment. Okay. It looks exactly the same. It would look exactly the same. That's my point. So whether you build it from the gutter or the edge of asphalt doesn't matter. Yeah. Okay, so I'm not going to finish this. Yeah, that's my point. It would create an equivalent model using a slightly different method. Right? So whether you add 2 plus 3 or 3 plus 2, you're still going to get 6. The details are different, but the result will be the same. Okay. So the last piece of the puzzle for the assignment is to get ready for lot grading. Okay, so what you want to do is, in the assignment, it tells you to create two point groups, existing and proposed. And I have styles for the point marker and the label, so you can review assignment 1 on how to do all that. But to create a point, a manual point, right? Forget what it looks like, but just to create a point, you go to points, create points. Very first button, manual, just create a point. I'm going to put one here at the end point. Elevation, just accept 0. Put another one here, and so on. Okay, so put a point into all the front lot corners. Once you create one point, you can create a copy of it. So I'm going to grab this. I'm going to go from turn your O snaps to end point. Okay, once you create one, you can create a copy, end point. Go to the end point, turn this on so that it knows how to sequence it. Number, endpoint, 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 go all the way around, all the front lot corners. That's on one layer, in one group. You remember we had different groups with different layers? We're going to do the exact same here. So I need a layer for the front lot corners, that's the proposed elevation. I need a layer for the rear lot corners, that's the existing elevation. And I need a group for each, because you're going to have a different style for each. Okay. So you put elevations at the front, you put elevations at the back, same technique, right? You put points at the back, okay? And then to put them into different groups, yeah, I'm using the end point of the lot lines between lots, yeah, the end point of this. You could use intersection if you want, but it's the end point of the line, really, front and back. That's a style issue, so you go into, you create a copy, so you go to settings, you go to point, you go to point labels, label styles, you make a copy of the standard one, change the name, elevation only, whoops, elevation only, and then you go to the layout tab, and you can either delete or turn off the other two, right? So the number I don't want to see, make it false, and the description I don't want to see, make it false, right? Or you can delete them. It's up to you. If you don't want to see them, you could actually delete the component and have just an elevation shown. Right? This is review from assignment 1. You should be able to do this. 2 styles. Okay. Then once they're on different layers, and once you have them, different layers is critical for this assignment. Then I would use the intersection. Yeah, if the drafting is sloppy, I would use the intersection of the street line with the lot line. So if that's a problem, put it on the street line. Okay, so for the exercise that you're going to perform, the layer that the points are on is more critical than the group that they're in, although you need to do both. And the reason for it is, I'm going to show you mine again. I'm going to get rid of these. So that's how you create the points, right? You create that, and again, if you want, like, let's say I want all of these to be the same. I want all of these to have the same description, right? So not FG, but EG. Make sure the description is the same, because that's what you're going to use to put it into the group, right? Same thing here. Make sure the description is the same. So the front lot corners are proposed, FG, and the rear lot corners are EG for existing. Okay? So they need different descriptions, and they need different layers. And then the different descriptions is how you put them into different groups. Okay, so review assignment 1. Okay, there's a lot of stuff there that you're going to redo here. You need to create the groups. You need to create the styles for the groups. You need to put them in the group based on their raw description. And you should have 2 of them, existing and proposed. And then we're not going to use description keys, but when you create the points, make sure you put them on different layers. Okay, so through the magic of television, because I don't want to waste your time, I've created my 2 layers. Created an existing ground layer and a proposed ground layer with points on them. I already did the exercise. So you can see the front lot corners in red on one layer and the existing ground elevations at the back are shown in gray. Okay? Now, the color, the style, that's in the assignment. Okay? What you're seeing on screen is just an example. What I asked you to do in the assignment might be a little bit different. Okay? So do what it says in the assignment. Okay, so the point, I think it's a 2 decimal place accuracy. I think it's red and white, not red and gray, and so on. So just be mindful. This is a demonstration. It's not your assignment. Make sure you pick up the specific details from your assignment. Okay, but again, it's critical that they're on different layers. So watch this. If I click on one of these and I say right click, select similar, I grab all of them. Right? These are all my elevations at the front lot corner. Don't forget these 2, right, on this triangle inside the site. If I right-click and I say elevations from surface, and I use my proposed road, no, you can't, because you have different surfaces. That's the whole point. Say OK. Now I have all my front lot corner elevations. And I don't get lost in the numbers. I know these numbers are correct because my profile is correct, because my corridor is correct. And see how everything, it depends on the previous step. So if your design profile is correct, then your corridor model should be correct, then your corridor surface model represents correctly, and now these elevations can be, you can be confident in these elevations. Okay? If you had to calculate these one at a time on paper with from AutoCAD, you can get the station value of this point, right, from the horizontal alignment. Then you can get the elevation of that point from the profile, and then you can figure out how to go from the center line down the pavement to the gutter and up the boulevard to get that elevation. Imagine doing that calculation for this entire site all the time. Okay, so that's the advantage of this technique. And then at the back, same thing. Grab a point at the back, right click, select similar, everything on the same layer, the back lot corners everywhere, right click, elevations from surface, existing ground, say OK, and now you have elevations at the back. So now you have an elevation at the front, proposed, an elevation at the back, existing. What do you do in between? Tomorrow's lesson. I'll start to talk about lot grading tomorrow. Without AutoCAD, I'm going to do tomorrow some discussion about lot grading, what lot grading is required. So tomorrow's lecture is really an engineering discussion, not a Civil 3D AutoCAD discussion. I'm going to teach you about lot grading, because you have to know how to do lot grading in order to use Civil 3D to input the design. And so that's tomorrow's lesson. So this is basically what you need to have done for Friday. It doesn't take long to produce the points. It doesn't take long to get the elevation for the points. The time it takes to create that corridor surface model is what's important. If you don't do the corridor, you can do the front lot corners before you even start your design. You could do that right at the beginning because the existing ground surface is already available from assignment 1. Okay. The only exception to this technique, elevations from surface, are these 4 points here, or 6 points. How do you get the front lot corner here? And what we're going to do is we're going to assume that because this is a proposed subdivision, we're going to propose an elevation here that's comparable to if this rural road was urbanized. So what it looks like, if we go to the profile, just for reference, right? It has a, let me just draw this, from the center to the edge of asphalt to the shoulder, from the center to the edge of asphalt to the shoulder, to the shoulder. Yeah, just going to make a copy of this. So this is what the cross section of the existing road looks like. In the future, it's going to look like this. It's going to be urbanized. It's going to have a curb and gutter and so on, right? And remember, this is vertically exaggerated, right? 5 times vertically exaggerated. So right now there's a shoulder with a ditch. I want it to have a boulevard in the future. So what that looks like in the future is this. We're going to keep the asphalt pavement, but we're going to have a curb and gutter that goes down. Actually, I can take this from here. Polyline, I can go from here to here to here. This is 5 times vertically exaggerated, remember? I'm going to put a curb and boulevard starting at the original edge of asphalt. So I want it to look like this in the future. And one on the other side. Make sure, whoops. So in the future, this curb and gutter is going to match the edge of asphalt. So that's what it wants to look like eventually. We're going to keep the asphalt in the middle, and we're going to get rid of the shoulder and the ditches, and we're going to have a full section like that. Okay, so what that means now is what's the elevation at the front lot corner going to be in the future? And the rule of thumb is this. From the existing center line, we're going to go up 0.3 a foot, and that's the elevation we want to use at the street line. So whatever the existing centerline elevation is now, today, I'm going to use that number, add 0.3, and that's the proposed street line elevation. And that'll be compatible to the urbanization of the rural road to an urban section in the future. Okay. Does everybody understand what the design requirement is? I'm using AutoCAD to demonstrate what I'm saying. I'll show you how to do it in a moment. Okay. But do you understand why we're going to use the existing centerline elevation, add 0.3 vertically, and then use that number on the street line? Because that will be compatible to a future boulevard elevation. Okay. Now, is it going to be exact? No, but it'll be close. Okay. And some municipalities actually write that into your standard. If you're going to propose a new subdivision, the street line along the existing rural road, the street line must be 0.3 above the existing center. That's usually the rule. And if that rule's not in effect, it usually, as a rule of thumb, works everywhere. Okay? So here's how you do that. And this is described in the assignment for these 6 points. Okay? So all these points here, I'm just going to touch them. This blue dot, this blue dot, this blue dot, this blue dot, right? Oops, let me get that right. 1, 2, 3, 4 are born that way, and on this side, 1 and 2 are going to be created that way. So here's how you do it. I'm just going to draw a line across the street, perpendicular. Okay, and I'm going to do that all the way along. Perpendicular, 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 perpendicular. This is one technique. There's more than one way of doing this, but this is how I like to do it. So there's your typical section line, right? The cross section of the road. Then I bring back from my topo, go to my topo, and I find my center line of the topo, so T dash center line, that's the line in the center of the road. Right? That's the existing center line of the road from the topo. I'm going to trim now using that line everything that goes across. Then I'm going to make a copy of a point and put it right at the center line of the road. so now I have points on the center line. I'm going to take all those points, 1, 2, 3, 4, 5, 6. I'm just going to make sure, right click, elevations from surface, from the existing ground. So those are the center line elevations at the center. What I'm going to propose here is this plus 0.1, this plus 0.1, this plus 0.1. Okay? So I want to transfer these elevations horizontally and vertically. Okay, so here's the technique I use. You have to do it one at a time because these lines are all different lengths. Right? If you list the length of the line, they're not exactly center of the right-of-way. They're wherever the crown of the road is. So if you look here, you'll see 1062. If you look here, you'll see 996. If you look at this one, it's got 9903 and so on. So they're not right in the middle of the road, right? If this was a 20-meter right-of-way, and I offset 10, this should have been built here, but when you do the survey, it's not exactly in the right spot. So they're all a little bit different because this is not a proposed center line, but an existing center line that was picked up by a topo. So here's what I do. If you list these lines, you'll see they're all 0, right? I started with 0. So what I'm going to do is I'm going to make a copy. You got to do these one at a time. And turn my O snaps to endpoint. I'm going to make a copy of this point from this endpoint. Oops, I got it in the wrong spot. Elevation from surface. Sorry. Okay, so now I'm going to make a copy of this point, and I'm going to take it from this endpoint to this endpoint. And when I do that, it's going to keep the elevation. The elevations are now the same. If I copy this point from the node, and I put it on this endpoint, watch what happens. It becomes 0. Okay? So I don't want to do that. Don't take it from the node to the endpoint. Take it from the endpoint to the endpoint. Because in 3D, when I use this, the elevation of the endpoint is 0. The elevation of the endpoint is 0. So if I move this from 0 to 0, it'll just move it vertically across. It'll preserve the elevation. If I go from this 3D elevation, if you list this, you'll see the Z is at not 0. So if I take it from not 0 to 0, it's going to be a 0 elevation. Okay, so let me do that one more time. Copy this point from the end point to the end point. That preserves the elevation. Now they're exactly the same elevation. So you do that for each one. End point to end point. End point to end point. End point to end point. And do all of them. I'm only going to do this side, but there's 2 more on this side. Once you have them all, you can then use this technique. I'm going to move these points. This you can do all at once. This is a global command. Move this point, this point, this point, and this point. Enter. It's asking me for a base point down here. The base point, I'm going to start at the origin. 0, comma, 0, comma, 0. Okay? And from that point, where am I going to move these points? I'm not going to move them in the northing, so 0, comma. I'm not going to move them in the easting, so 0. Keep them at the origin so that they don't move in the plane. But I'm going to add 0.3 to the vertical. So I'm taking it from 0, 0, 0 straight up to 0, 0.3. 1 foot higher, 0.3 higher. Watch the numbers when I hit enter. So now 0.6 becomes 0.9, 0.2 becomes 0.5, 2.8 becomes 3.1, 2.4 becomes 2.7. I made a copy of this point, I put it here, and I raised it by 0.3. And that's the future proposed point. So that should be on. So these points here should have an EG description. You can keep them in your drawing. And these points here should have an FG description. Their proposed future. Okay, and that's one way of doing it. So in the assignment, it describes what to do. It doesn't necessarily show you how. This is how I would do it. If you want to, you could just make a copy, know what the elevation is here, put a point here, type the number in. Right? If you want, you can click on this, go to your properties, and just change the elevation manually. If you want to just type a number in. But this is a technique where you don't have to get lost in the numbers. I hardly ever look at the elevations. I just make sure things are coming from a surface that's correct and coming from moving it relative to another point. So I don't get lost in the numbers. I hardly ever look at the numbers in detail. I just make sure that I'm creating them correctly from known data that's good to a new thing that I know is relative to it correct. Okay, so that's the technique that you want. So then at the end of this assignment, you'll have all your front lot corners and your rear lot corners. In here, don't do anything. Only on the perimeter of the site. Only on the perimeter of the site do you need elevations, and only at the front street line do you need elevations. Internal, what to do here? That's assignment 4. So don't get lost there. Just the perimeter, the outside of the subdivision and the edge of the street inside the subdivision. Those are the only things you need to concern yourself right now. Okay, and then what you do with this information will come out in the next assignment. Okay, the other thing too, I don't know if it describes, let me just check. I don't remember if it's part of this assignment. It's a lot of work later. If you start on it now, it should go a little easier. So module 3, the assignment, let me just see if it describes it. I think it might. It might ask you to rotate the points, make it look good. Yeah, it describes. Okay, so let me show that as well. I can't remember if I asked you to do it here or not. So to make these drawings look good, what we want to do is rotate the points so that they're parallel to the lot lines. So here's how you do that. Let me just do one. So if I click here, right, just select it. Don't start any command. Just click on it so that the grips show up. Put your cursor right in the point, and then from this menu that shows up, rotate the label and the marker. Now you can rotate. Let me turn my ortho off. You can rotate it. And if you pick a point near, now it's parallel to the line. Right? But then you can't read it. So then what you can do is take this and grip edit so that it's off the line. And now it's legible. If you don't want to see the leader, then you can go to the style for the marker. So if you go to the label style, which is in the settings, under label styles, you're going to have a different name, obviously. If you go to the dragged state, you want to make sure that your leader is false, off, and as composed. Right? So if you don't want to see your leader, which you probably won't, this is how you turn it off. It's in the dragged state, and then your leader should disappear. Right? So now if you drag this away, there's no leader. There's no leader visible. Okay, let me show it again. So click here, go inside, choose the middle one, snap to the near point, and don't do this by eye. Make sure you snap to the line. Make sure it's exactly the same. And then now you can't read it. Put it either above or below. Make it clean. Make it look good. Okay, if you don't like the decimal place accuracy, again, you go to the style, update your group style, and then I go to, again, I'm changing the standard one. Don't do that. Make sure you make a copy. Don't worry about the rotation. It'll take care of itself. Okay? So if it appears upside down, leave it. I'm not going to worry about that. Go to Edit Style, and then if you go to Layout under Elevation, if you click in the contents and you click on that button, it's called the ellipsis button. If you click on that code, you can change it from 3 to 2. That's what you want. This is your wish list. In order for that to happen, you got to click this little arrow here. So see here it says P3. Click on the arrow. Now it says P2. Say OK. Say OK. And now they're all 2 decimal places. Okay, so you change your style. Let me demonstrate the rotation again. So click on the point. Go inside. Near. And then it's through the line. And manually move it. And off you go. So you can start to clean that up. This one here in the back, you can go this way. Watch, it'll actually rotate. See how it's this way? And if I go over a certain angle, it flips the text so that it's legible. So let it just do its thing, Stephen. Whatever it does, just accept it. Near, and then grip edit and put it above or below. Be consistent. Okay, so now it's a nice clean look. There will be more points in between, but you can at least get started with the rotation. Okay? If you don't do this now, you're going to have to do it later. Okay? At the end of assignment 4, it should all be designed and drafted. Okay? So if you don't do this now, you'll have to do it later. Okay? And I've asked for it on this part of the assignment. It's just a little more, it's just drafting. It's just cleaning it up and making it look tidy. Because if you look at a grading plan, let me see if I have one here. I think I do. If if you go to any grading plan, let me see if I've got one here. Hang on a second, let me find one. If you look at a grading plan, see if I can find one here. Share this with you. Here's a grading plan. This is one I worked on when I was still in. Working in. So you can see all the points, right? There's a front lot corner. There's a rear lot corner, and then there's some points in between. And notice they're all parallel to the side lot line. So everything is very, very parallel. And even in here, if it's not parallel, then it's usually perpendicular. So it gives it some kind of order. So let's see another one here. Yeah, here's another clean look. Right? Front corner, backyard, and then something in between. There's a lot more information here than we're going to produce, but this is what a grading plan looks like. Right? So you always want the points. And remember, north is this way. So it would come in readable to true north. These are all rotated. All these points are manually rotated. Sorry about the phone, guys. The points are all manually rotated, so they're parallel to the line. You can see here, right? Front corner, back, and then 1, 2, 3 points in between. I'm going to teach you how to produce everything in between in the next assignment. Okay? I just want to give you a preview of the kind of stuff we're going to be producing. Okay, I think that's it for today. Again, just a little more demo of what the assignment's about. For the corridor, I have gaps on both sides of the elbow. As long as those gaps are closed on the surface, right? So if the corridor looks like it has gaps, as long as when you see the surface, there's no holes in the surface, it's okay. After I trace my line for the outer gutter, my crescent, I zoom in and they're exactly on top of each other. Use a regen command. It's sometimes just the video card playing tricks on you, right? So when you zoom in, it doesn't look. Let me show you if I can show you mine. Share my screen again. So if you're way out here in your regen, right? If you zoom in, might not look like a curve. That example. That looks like a circle. But when you zoom in, it might not look like a circle. It's a bad example too. Hang on a second. My video card's pretty good actually. Didn't share your screen. Okay. Can you see my AutoCAD screen now? Okay. I'm trying to recreate this problem. I'm not sure. Well, I've got a pretty good video card on my. I know exactly what you're talking about. The one thing you might look at is in your options, OP options. If you go to display, you might want to consider changing the smoothness here. So if this is low, I'm going to call it 10. Things might not look so smooth. So if I draw a circle here and I zoom in on it, it might not look like a circle through your regen. Yeah, I've seen that before. My GPU is my computer. from? You're talking about my computer set, my computer, my graphics card? I'm not even sure where to find that. If you walk me through it, I'll show you. It's probably under my computer settings, I think. Check my desktop. I still have it here. I used to have my computer settings. No, I deleted it. I'm not sure where to find that. Yeah, I'm not a computer guy. I use the software, but when there's a problem, I have to ask somebody about it. But mine seems to be pretty good. But you might want to try that in the options. Under display, you might want to change this, make it a little bit bigger. But too big starts to bog it down. Too small is no good either. So really, try that. When you zoom in, if it looks kind of jagged, just regenerate, R-E-G-E-N, or regen all is another thing. And that kind of refreshes the view. Any other questions? Let me see. How did you mark the overall appearance presentation? I just got 1 or 2 out of 4. If there was things missing, one major thing I looked at is the legend. The legend had to represent. It had to be the same size. I saw this was one of the biggest issues. I can show you that technique too. If you go to the layout, the legend, when you're drawing your sewers, right? So if I suggest something here, right? If I draw my, if I offset by 1.5, right? Offset 1.5, and I draw a circle near of 0.75 and 0.75. If that's the size, then you want to have the same size in the legend. Right? So if that's what it looks like, let me just color code these. I think this was the sanitary. This was the storm on my drawing. I can't remember. Just as an example. So when you see that in your plan view, right, you can't draw a circle in your legend that's bigger and have the same color. It has to be the same size in the legend that you have in the plan view. It has to be representative. So that's one of the things. That's one of the things I look for. So the legend had to be the right size, and some people didn't get that. Right? They had huge. Like their legend was huge. It didn't look anything like what they were showing in the plan view. So I took a mark off. Right? It had to be representative. Right? That's what a legend is. It has to be the exact same item or similar looking item with a name next to it. If I Control Alt Delete, go to the Task Manager and click on Performance, then GPU. Okay, I'll take a look at that. The corridor should only show for the middle of the elbow. It didn't reach the extent of the sides. The corridor would only show for the middle of the elbow. I'd have to look at it, Michael. I'm not sure what you're describing. So that was one issue related to the legend was the biggest issue. That's one mark. What you show in the plan view. So when you're looking at the plan view, you shouldn't see anything related to grading, right? So there should be no existing ground contours or no surface information here, right? So there shouldn't be anything in the plan view that's not related to servicing, right? So no elevations, no contours. So I made sure that you weren't showing anything like that. So there was some layer control. Same thing with how you centered it in the drawing, if it looked like it was placed properly. So there's a lot of different things. If you want me to review yours with you, we can look at that together. And I can find at least 4 things that's wrong with it. I didn't get too picky, but there's always something you can do to improve it. Okay, so they're in the middle. It didn't reach the extent of the sides. Mike, are you still talking about a gap in the corridor model? Yeah, so look at your surface. If there's no gaps or holes in the surface, then don't worry about it. because you can still build a corridor surface even if there's gaps on the corridor. And if I bring my corridor back, so if I bring my corridor back, right, if there's a gap here, right, see here, mine has a gap. You actually look at my object here. Is this what you're talking about? See here, there's a gap. Is that what you're talking about, Michael? Okay. If that's there, but then it doesn't. If the surface is fine. Let me just show you my surface is okay. Whoops, my surface. The surface will actually go right through that gap, and you don't see anything like that. It's fine. Okay. So the gap you see on the corridor, if it doesn't have an issue on the surface, then it's fine. So did you check your surface, Michael? Okay, yeah, we can have a separate discussion for that. Yeah, we can do that. Explain what you are looking for. Paper space presentation. 500 things. If you get one or two wrong, I take a couple of marks. That's a hard question to answer, Stephen. When it comes to presentation, as soon as there's something blatantly out of sorts, then I look. Would you allow me to look at your PDF now in front of all the class, or do you want me to do that in private? We can have a private discussion about that. I don't want to show your work. Oh, in the paper space, the setup for paper space model, yeah, that's easy. I can show you. That I can explain. Okay, so when I check your drawing, I open your drawing. First thing I do is I list both of these frames. This should be 2xp, right? Or if you look at one at a time, it should be 1 to 500. Am I sharing my screen? I'm not. Hang on. I'm not sharing. Hang on. Share screen. Entire screen. So for paper space model space setup, this is what I did. So when I open up your drawing, I do your paper space model space, I list both of these frames, and I make sure they say 2xp, which means if I click on one, it's 1 to 500. Okay, 1 to 500. So that's how I know the scale is correct. That's part of the technique. The other thing I look at is, did you rotate this correctly? So when it comes to the rotation, I'm referring to assignment 3, not assignment 2. Can you please explain what you are looking for in the paper space presentation for assignment 3? In assignment 3, it looks like a grading plan. Okay, I'm going to go back and get the assignment 3 requirements. Let's just look at it. Oops, presentation. Oh, for this piece, planning profile setup. Yeah, so this is what the drawing should look like. The bullet point, yeah. So to create a grading plan, you're going to create a new layout. So click on the layout, right click, make a copy. So make sure you choose, move to the end, create a copy. Say OK. Now you have two exactly the same, right? So this is your plan profile. You're going to need this later. This is your grading plan. In the grading plan, there's no profile. And you can just center this in the view. That's your grading plan. And then in the plan view, there should be nothing related to any modeling you do. So I don't want to see the corridor. I'm going to freeze the corridor here. Shouldn't show the corridor. And shouldn't show any underground layers. Right? So the two basic drawings, plan profile and grading plan, are focusing on two different things. You're doing all your design in one file, so all the information is in model space. All the information is in model space, but you don't want to see everything in model space in each drawing. So in paper space, when it comes to the plan profile, there should be nothing related to grading. So no point elevations, no contours. When you do a grading plan, it represents what's on the surface of the ground. So you shouldn't see anything underground. So no pipes. Maintenance holes, yes, but no pipes. And so on. I'm going to talk more about that as we get closer to the end. I'm not going to be too picky, but certainly some things you never want to see. Okay? Like the corridors you don't want to see. The additional alignments for the gutters you don't want to see. Any points you use to project to do your work you don't want to see. Any construction lines you use you don't want to see. Only the design information. It should be exactly the same. Yeah, because the view is the same. I'm just using the view without the profile, right? So if you look at that view and this view, they're exactly the same. They should have the same north line. Yeah, so how to create the view for grading. So if you go to this is the one you created for assignment 1. If you right click on the word layout, you go to copy or move. Make sure you move to the end and make sure you create a copy. Say okay, it creates another view. Once you have that copy, you can delete the profile view and just center the plan view. And then in this view, you shouldn't see anything underground, only your point information. And your existing ground contours, but we'll get to that. I think the PDF shows that. Right, so make a copy of the Paperspace layout the way I showed, then for the layout view, delete the profile, maintain the viewport scale, make sure all underground information is not showing on the grading plan, no pipes, no pipe labels, do not show the existing ground, do show the existing ground contours, so you want to see the existing ground contours, and I think there's something in here about, where does it show the existing ground contours? Freeze the layers through the viewport, not model space. Yeah, that's another technique you should be mindful of. Should the pipes be in different layers? Yes. I'm not going to be too picky about that, but yes, they should be. You can't freeze one and keep the other, right? So in here, because we're going to replace these later, but these, the maintenance holes need to be on one layer and the pipes on another. So if you want to use a SAN MH and a SAN pipe, you can do that, and then they're on different layers. So if I put these on different layers, if I put these in a different layer, just whatever, right? If you go to the viewport, you can do this. Like this is the technique you need to be mindful of. So this is a grading plan. If you go inside the viewport and you zoom in on that, you can freeze, use the freeze command, freeze the pipe, yes, freeze the pipe, but leave the manholes. So now in the viewport, if you go to your viewport settings, see here, there's on, and freeze, on, off, freeze, thaw, the first two columns. And then when you're in the viewport, you get this extra column. You can actually freeze layers in the viewport. Right? So I just took never mind the layer name, right? I can freeze a layer through the viewport. Or you can freeze it, and that freezes it in every view. Right? So you have to make use of this column. So you can do your layer management. Maybe I'll talk more about this tomorrow. You can do your layer management through the viewport. So in model space, you see everything, servicing and grading all mixed together. But in this view, you want to freeze any layer that's related to grading, and in this view, you want to freeze any layer that's related to servicing. And that's the basic technique. That's what it's talking about. So if you want to show the maintenance holes and not the pipes, yes, they need to be on different layers. Talking about presentation and assignment 2. Yeah, I'm not sure exactly what else I looked for. I did look at this setup, right? So make sure these are the correct view. The rotation of the plan view had to have the text horizontal to the view. So if I draw a line from this point horizontal with my ortho on, it should be parallel to the center line between this piece and this piece all the way to here, right? So that there's a piece of the road that's horizontal to the view, which is actually parallel to the text. That's what I asked you to use for reference. And then if I draw a line from this point here, station 120, if I draw a vertical line, it should go right through station 120 on the grid, right? Because you line this up to match. So I can check that you did that properly. So the scale and the horizontal piece of the alignment is directly above the profile for the same station range. That was the other thing I looked at. Okay, I'll talk more about presentation tomorrow. That's one of the last things. You can't do presentation until you create all the information. So if you start the assignment tonight or today and you have some information to work with, I can show you that technique again. Okay, and I'll do a little bit of layer control through the viewport tomorrow. Okay, but come ready tomorrow with your calculators and your pen and paper. We're going to do some math. Okay, that's it for today. If you have any specific questions, email me, and I'll try and answer them through the email, or I'll set up a meeting so we can do a video chat and look at specific details.